Good morning, guys. We are on day 5 of our coronavirus-induced NTI extravaganza, and we're getting ready to talk about inequalities involving quadratics. So far, this class has gone pretty well. You guys are used to the videos. I've only had one class, my Algebra 2 class, that I've not really done videos with, so this is a learning curve for them. It's nothing new to you guys. I'm hoping that things are going well because I've not really heard from any of you. I'm hoping you're able to watch the videos. I'm guessing that maybe my videos are so fantastic that when you look at the suggested problems, you have 0 questions. You know exactly how to do it. So maybe that would explain the lack of questions that are coming my way. We are going to address a few things in our Zoom class this afternoon, one of which is going to be you do have a quiz today. Don't freak out. The quiz is just like what it's always been. It's going to be over sections 2.2 through 2.4, I believe. I'll have to double check that, but it will not include this set of notes. You guys still receive grades in this class. That is a university requirement. It is also a high school requirement, and your grades are still going to be received the same way they have been. It's going to be strictly off of quizzes and exams. And we'll talk about a lot more of this when we meet later on. The notes that we're looking at today are quadratics involving inequalities, or inequalities involving quadratics. And they're not difficult. The solutions are relatively simple, and we're going to just jump in and look at an example and kind of explain it as we go with the example. Now, had I been more of an effective math teacher, you guys would have already had a coordinate plane on your notes, but I did not do that because I'm not any good at my job apparently. We will look at example 1. Solve the inequality x squared minus 4x minus 12 is less than or equal to 0. I'm going to reach over here and grab my power cord real quick. And what we can do with that is treat that just like a regular inequality. Let's first factor just the inequality that the quadratic side of the inequality. We have x squared minus 4x minus 12. We know that that will factor into x minus 6 and x plus 2. If you're not sure about that, you can go to Desmos to verify this quadratic. I've already typed it in there. You can see the zeros are -2, +6, and that's exactly what we found with our factored form. So let's go back to the factored form, because the zero product property tells us that if any factor is equal to 0, the quadratic itself is equal to 0. So we get x equals 6, x equals -2. And graphically, that's going to look like 3, 4, 5, 6. So here's one of our zeros. Here's our other 0. Really, you don't have to graph these on a coordinate plane. If you can find the zeros and the vertex, if you wanted to graph it, then everything's going to be fine. But really, once you find the zeros, you've found the solution set. But let's go ahead and finish this one out, and then we will continue with the other examples without going through the entire process. So the next thing that I want to do is find the vertex. Remember, the x-coordinate of the vertex is -b over 2a. So my vertex is going to lie at -4 over 2, and a happens to be 1. So we get 4 over 2, which just reduces to 2. And then we can plot that, or substitute 2 into our function and evaluate it to find the corresponding y value. And we simplify that. We get 4 minus 8 is -4, minus 12 is -16. So our vertex lies at 2, -16. So right here's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere down here is our vertex. So our graph looks something roughly like that, very rough. But what we're interested in is the inequality itself. It says that this quadratic is less than or equal to 0. So what values make this graph lie below the x-axis? Where is this graph below 0 on the x-axis? And this portion of the graph right here is what lies below the x-axis. So it's from our x-intercepts of -2 and 6, and because the inequality is less than equal to, we will include those values. So this function, the solution set, will be x such that -2 is less than or equal to x less than or equal to 6. That is your solution set for that inequality. If it was greater than or equal to, then we would go in the opposite directions. We would be looking at the left-hand side and the right-hand side using the zeros as well. But for now, for this one, it's less than or equal to, so it's everything in between -2 and 6. With example 2, solve the inequality. 2x squared less than x plus 10. So we need to work on this one first. We have 2x squared plus less than x plus 10. So let's subtract everything on the right hand side, move it over to the left, and we get 2x squared minus x minus 10 is less than 0. With this one, we want to try to come up with the factors. We're going to have to use AC factoring on this one. So 2 times -10 is going to be -20. And we want to find the factors of -20 that add up to -1. We've done this in class. Fortunately, we were together when we did this. So the factors of -20 that add up to -1 are -5 times 4. -5 plus 4 is, in fact, -1. So now we can factor this out. So we get 2x squared minus 5x plus 4x minus 10 is less than 0. When we do the factor by grouping here, we have x, 2x minus 5. We can factor a 2 out of this side. We still get x minus 5. And we now have, sorry, there's a 2 there. We have x plus 2, 2x minus 5. And this gives us, this term gives us a 0 of -2. This term gives us a 0 of +5 halves. This time our inequality is strictly less than. So we do not include our zeros in the solution set. So for the solution set on this one, we get x such that -2 is strictly less than x, which is also strictly less than 5 halves. And that is the solution to example 2. For example 3, we have an inequality where we're looking at it's greater than. Now, for example 3, you guys may not think to test this initially, but it's one thing that you'll probably want to start to learn to consider. We know that this graph does open up because the term on x squared is positive. We can also look at 3 times 14, which is 42, but we can also come up with 0 real factors of 42 that add up to 12. So we could do the quadratic formula to find the zeros. So let's do the quadratic formula. -b plus or minus the square root b squared minus 4ac all over 2a. And if we label this a, b, and c, we have an easier time of substituting everything in. So opposite of b, plus or minus the square root of b squared minus 4 times a, which happens to be 3, and c, which is 14, all over 2 times a, which is 3. So when I simplify this, I get -12 plus or minus the square root of 144 minus 168 over 6. And that simplifies to -12 plus or minus the square root of -14 over 6. If you recall anything that we've talked about with quadratics, we need to pay close attention to that discriminant. Remember, the discriminant is the portion of the quadratic formula that lies under the square root. If the discriminant is positive, then we have two real solutions that are not equal to one another. If the discriminant is 0, then we have one repeated solution. And if the discriminant is negative, it means we have no real solutions. So what this means for this particular graph is that it never crosses the x-axis. And since we know the graph opens up, the graph will look something like this. So in that case, this graph is always above the x-axis because we're looking for where is it strictly greater than 0. And so it is a case where you have x is between, it's either, you could put x as an element of the reals because it's all real numbers, negative infinity to positive infinity. You could do x such that x is between negative infinity and positive infinity. Or you could do interval notation, negative infinity, positive infinity, however you want to do that. But because this graph lies completely above the x-axis, we know that it cannot be less than 0 or equal to 0 for that matter at any point across its domain. If you wanted to verify that graphically, 3x squared plus 12x plus 14, we have 3x squared plus 12x plus 14. Okay, I'm going to zoom in a little bit here. Here's the x-axis. The graph is completely above the x-axis, so it never is less than 0, so it has to be all real numbers. If that graph happened to, say, have x-intercepts at -5 and 0, if we're looking at strictly greater than, then the graph would be above the x-axis from negative infinity to -5, and then it would be from 0 to positive infinity. We have multiple solutions. So go ahead and start looking at these suggested problems because these will appear on next week's quiz. I'm looking forward to seeing you guys in our Zoom meeting at 11, and I hope everybody is doing very well. I'll talk to you soon.